Yeah, so what this is basically it's a way to generate and parse sentences in English and Italian. So I'm just going to type a phrase, the pizza. Okay, so what this is doing is generating similar phrases to what I've typed, and so I can. So it's kind of hilarious, and I love to just watch like what crazy things. And a lot of the funniness comes from the fact that it's a small, a pretty small system, a toy, lexicon, toy dictionary. So it's really funny. It's really funny. So I'm glad people are laughing because I laugh at this stuff, and I'm just so amused by playing with this system. So that's just a noun phrase, right? The pizza. But you can also say like I eat the pizza, right? So I eat the pizza. Okay. Now what's going on is it's instead of getting pizza, it's treating eat as the thing that it's kind of building on, and so that's what I've been working on lately. And yeah, so how is it working? Well, here's a parse tree. Talking about trees, Zach talked about trees and DAGs. So this is a tree, but really, I mean, JSON can't represent a DAG, but really it's a DAG. And so actually, there's interrelations between the parts of the tree, and it's all based on head-driven phrase structure grammar. Pretty. As these things go, it's pretty old, from the 80s, but I think it's great. It's still a great theory. So these little ones here, those are like so imagine this is like a tree, but those ones indicate like shared structure in the tree. So I wrote a library in Clojure to implement like instead of just a map is a tree basically, but so I wrote like a DAG, directed acyclic graph. Library in Clojure, on top of that to account for that, so I could implement this theory. Now, going back, the sentences are really hilarious, and it's still generating them. And we'll go back to that at the end. We'll just let it run. But so what it's doing is like it's looking at the parse, right? Just taking the first. There may be multiple parses. Just take the first one. Some things it's gonna say, all right, I want to generate some sentences based on this. I'm going to generate some things. About the sentence that I want to generate are required. So I'm going to take these things here, and then I'm going to optionally take some of these. Like there's 4 things here. It's going to try to find these 4 things, and it's going to take between 0 and 3 of them. So it's going to take some subset of those. So it's just going to mash everything together and generate a sentence based on that, and then you get a hilarious sentence based on that. And So here's what the underlyingly what the dictionary looks like. Here's pizza. I showed pizza. So that's all there is about pizza. It's just it's a noun, and it has a semantics, which is simply this keyword pizza, which doesn't really mean anything except there's also an encyclopedia here, and what this encyclopedia means, like this is all the things in the world and what they are. Like imagine talking to a computer that never ate pizza or doesn't know what pizza is. Well, it's an artifact. It's something we make. We make a pizza. We don't find it on the ground in nature, and it's edible. You can eat a pizza, right? And based on that, the computer is going to generate there's all these inference rules based on that. So, for example, if something's edible, there are certain things about it. It's consumable, and it's not drinkable. Maybe soup might be edible and drinkable, whatever. So these are all just like this like handmade like ontology or inference rules about the world. That I just wrote to generate sentences that are hopefully like they're kind of funny, but they'd be even funnier if you could have like pizzas eating cats or something. That would be even crazier. So these inference rules make it less crazy than it would be otherwise. So let's see. What else do we got? Yeah, it's just fun. I'm so glad people are laughing. I'm serious. And so like here's another inspiration. Like Zach talked about Babel, or talked about Borges. In the Library of Babel. So I'm not on the net right now, but I don't know if you guys heard about this, but like this person, Jonathan Basile, implemented the Library of Babel. So what it is, it's just like random, characters in the of all the books that could be written in the world and or in of all time. And so like the true story of your life is in there somewhere if you could find it. If you could search for it, you could search for your name or something. So, but most of them are just garbage. They're just like random letters together. So I thought, well, what if we made it so at least they're grammatical sentences. So, like I'm sure we've all eaten pizzas, right? I mean, the true story of your life has pizzas in it, right? So you can like just get rid of a whole bunch of books by just concentrating on pizza. So if you search for pizzas, maybe you did some of these things, right? So, yeah. So and then last of all, GitHub. So this is kind of the basis of it all. dag-unify. It's like unification is the way we join together graphs so that in a way that combines them, kind of like conj does or merge does in Clojure. So this is on GitHub. It's open source. My username is Eugene Koontz. That's my name. And so it is under the the Clojure license, the EPL. So the natural language stuff or the dictionaries and all that, I haven't quite decided what to do. I'm going to release that eventually. But for now, like this is the start. This is like the foundation of it. So so feel free to like nobody cares about it yet. But if you care about it, that would be great. So thanks a lot. All right.
Questions?
Yeah. So it's a very small. I apologize, but I would like to make it bigger and like make it automatically just use Wiktionary or something to get all the data. But
there are wiki ontologies that you could probably import.
Oh, great. Yeah, thank you. That's a great idea. Yeah. But so I don't know what does anyone want to see something like Italian? Oh yeah. So right. Yeah. So io mangio.
Io mangio la pizza.
Yeah. I don't have pizza in Italian. It's pretty. I think I have. It's pretty sad. I'm sorry. I have pane. How about that?
Okay.
Yeah. Okay.
Double N.
Okay. So now the Italian is even crazier. Yeah. So.
I don't think you got pane, right? Pane has two N's.
Yeah. Well, actually, it's treating mangio as the thing it's looking for. So it's but if we just take pane, then we'll get a bunch of pane. So let's try that. Okay.
How do you slow it?
Does it's slower? The black bread, the yellow bread, the white bread, the beautiful bread. Yeah.
Fun. The happy bread.
The difficult bread. So could bread be difficult? I don't know. We have to put that in our ontology. Like only things that could be understood can be complex. Yeah. Right. Yeah. So we have to put that in our encyclopedia. We have to put that in our. Yeah. So yeah. Anything?
I have a question.
Yeah.
Is there anything about Clojure that helped you make this?
Yeah, Clojure is great. I love Clojure. It's just so fast to iterate. I mean, it's just like I'm trying to think. It's just like I can change something in Emacs and then just save it and like the web browser will automatically see it. I like something I don't know how that's even happening. It's like Ring is doing that somehow. What?
Big word, right?
No, it's not Clojure script. It's just regular Java Clojure. But so I don't quite understand how that happens actually.
Ring auto reload.
I guess so. Is it in my project CLJ? I guess so. It must be. It must be something I've set or some default.
You set it.
Yeah. But it's really like fast to iterate. I don't know. But like compared to another language, I don't know.
A lot of mileage out of the data structure literals, especially.
Yeah, the maps.
I think that would translate well to like a Java or something else.
Yeah, right. Being able, and just the macro, like the arrow macros. It's very concise. It's very fast to write stuff, but you do have to get used to it. It's like meta. You have to just like learn it. Yeah.
Is the DAG unification map so difficult that you need a library for it? What was so hard about it?
Well, I had to. I mean, I implemented with. Well, yeah. How is it difficult? I mean, like you need to have a way to say like there's two ways to get to one thing. Like so you need to be able to like have a get in. You can like have get in and then a map and then a path. And you need to have a way so that you end up in the same place. So I implement it with an atom, and so that's how I did that. So like I use like when you unify and you have something where they become equal, then like I use a atom and I like alter the atom to be the result of unifying the two things that would be like we're at that path, that we're at the two paths. They're one. I mean, there's two paths to one value, and so that value is the merging of those two values, and then you unify the atom so you can get to it from two different ways.
Is that performant?
Yeah. I mean, it used to be a lot slower. I made it faster, but it could use a lot more work, I feel like. But I feel like it's fast enough. I mean, it's fast enough to like parse things. Like I can just type stuff and it will keep up with me. But like at scale, I don't know. Like Yeah, it's fast. It's fast enough to keep up with this demo, so to be entertaining. So, yeah, but it wasn't fast. Yeah, yeah. Sleeps. It's ambiguous. Yeah. Sleeps has many meanings in English. Yeah. So, yeah. Thanks. Yeah.